Hey guys, today we're going to learn how to use completing the square to first solve quadratic equations, and then secondly how to write quadratic equations in vertex form. Let's start with completing the square, using completing the square to solve quadratics. Sometimes quadratics are not factorable, and maybe you do not want to use the quadratic formula. So completing the square is another alternative that's really helpful to use when you get into pre-calculus and calculus also. So the very first thing you want to do is you want to make sure if there's a number other than 1 out in front of the x squared that you divide everything by it. In these questions there will not be a number other than 1, so we could skip that step. Step 2 is to isolate all of the x terms. So I'm going to add 14 to both sides. So the only terms I have on the left side have x's in them. Next, I'm going to do the process called completing the square. To do this, you take your b value, which is your number in front of your x, and you divide by 2, and you square it. So I'm going to take this 2, which is in front of the x, divide by 2. That gives me a 1, and I'm going to square it. So I'm going to add 1 after these two terms. I have to, if I add 1 to the left side, I have to add 1 to the right side. So again, I took the number in front of the x, I divided it by 2, and I squared it. So 2 divided by 2 is 1, 1 squared is 1. I have to add that to both sides, because what you do to one side, you have to do to the other. So now what I have here is a perfect square trinomial. This trinomial is factorable, and it's not only factorable, it is something times itself. So what numbers multiply to 1 and add up to 2? 1. So instead of writing x plus 1 twice, I'm going to write x plus 1 squared. And on the right side, there's a 15. So now the beauty of this process is you went from having 2 x terms in your equation to now only having 1 x term. So we could solve for x by just undoing what's happening to x. For example, let's undo squaring by square rooting both sides. And remember, the square root of a number could be positive or negative. For example, the square root of 9 is not just 3. It could be negative 3 as well. So when you square root both sides, make sure you put a little plus or minus sign in front of the radical. So squaring and square rooting cancel. Next, we want to undo this adding 1. So let's subtract 1 from both sides. So our roots, or x-intercepts for this equation, are positive radical 15 plus 1 and negative radical 15 plus 1. And again, what those are values where this parabola crosses the x-axis. So the square root of 15 is like 3 point something. So we have negative 3 point something plus 1, which is like right here, and positive 3 point something plus 1, which is like right here. So that's where the parabola is crossing the x-axis. Our next use of completing the square is to get our quadratic in vertex form. Vertex form is y equals a times x minus h squared plus k. So we want this to look like this so that we could see maybe any potential transformations or the vertex. So it's very similar to what we just went through. You want to divide everything by any number that's in front of the x squared. We don't have one. You want to isolate the x's, so we're going to add 48 to both sides. Y plus 48 equals x squared plus 8x. Same steps. Next, we want to take the number in front of the x, divide it by 2, and then square it. So 8 divided by 2 is 4. 4 squared is 16. So I'm going to add 16 not only to the right side, but to the left side. The whole point of this is that you now have a nice factorable trinomial on this one side. So what numbers multiply to 16 add up to 8? 4. So x plus 4 times x plus 4, in other words, x plus 4 squared. And you could see this part of vertex form is starting to form. 16 and 48 is 64. So this is y plus 64. And then the final step is to just get it to say y equals. So it looks like this. So I'm going to subtract 64 from both sides. And our final result is this. And now you know, if we compare the vertex form, there needs to be a minus here. So I'm going to change plus 4 to minus negative 4. So our vertex would be negative 4, negative 64. Our a value is 1, so we know it's positive. So you know negative 4, negative 64 is way down here, and it's a smiley parabola. So it kind of looks like that. So please let me know if you have any questions, and have a good day.